How can a telescope look at a tiny dot in the sky and literally see billions of years into the past? Because light has a speed limit. Every time you see something, you're seeing it as it was when its light left. The sun you see right now. That light started its trip about 8 minutes ago. A telescope just does the same thing, but with much older light, faint light that's been traveling for billions of years. This is the whole trick. Distance in space becomes distance in time. A light year isn't time, it's distance, how far light travels in 1 year. So when a galaxy is a billion light years away, you're not seeing it now. You're seeing it as it looked a billion years ago, when dinosaurs still walked on Earth. But there's a problem. Old light is weak. By the time it reaches us, it's spread out across an insane amount of space. So the first job of a telescope isn't magnifying. It's collecting, like a rain barrel in a drizzle. A bigger mirror grabs more photons, so you can detect objects that are otherwise invisible. Then comes patience. Telescopes take long exposures, sometimes minutes, hours, even many nights, adding up tiny counts of light until a picture emerges. It's like trying to hear a whisper in a crowded room. You don't get it in 1 second, but if you record longer, the signal becomes clear. And modern detectors do what your eyes can't. Your eye resets constantly. A camera sensor can keep collecting. It can also see wavelengths outside human vision, especially infrared, where ancient galaxies often glow. That's why many deep universe images look like magic. They're built from light you were never able to see directly. There's another twist. The universe expands while the light is traveling. So that ancient light gets stretched, its wavelength becomes longer. That's called redshift. The farther the galaxy, the more the light is stretched toward infrared. So, seeing farther often means seeing redder, and telescopes designed for infrared can catch light from the earliest eras. On Earth, the atmosphere blurs starlight, like looking through a swimming pool. That's why observatories sit on high, dry mountains, and why they use adaptive optics, mirrors that flex hundreds of times per second to cancel the shimmer. And it's why space telescopes are so powerful, no atmosphere at all, just clean, stable light. So when we say a telescope sees billions of years into the past, it's not a metaphor. We're catching photons that have been traveling since the universe was young. Each deep image is a fossil record made of light, showing galaxies growing, colliding, and changing over cosmic time. And there's a hard limit. Go far enough back and the universe becomes a hot fog that light couldn't travel through. Beyond that, you can't see with regular light at all. You need other messengers, like the cosmic microwave background, or even gravitational waves, to learn what came earlier. Now here's the next question. How do scientists know those tiny smudges are real galaxies and not just noise in the camera?